Welcome to Viewers. I, Dev Hara, undergraduate at Indian Institute of Technology, Mandi, Himachal Pradesh, pursuing Bachelors of Technology in Mechanical Engineering, will try to explain one of the techniques of machine learning which can be used in field of fluid mechanics. Nowadays, machine learning gives us enterprises a view of trends in customer behavior and operational business patterns, as well as supports the development of new products. Many of the today's leading companies such as Facebook, Google, and Uber make machine learning a central part of their operation. One of the ongoing projects of IIT Mandi is predicting landslides via machine learning's deep learning approach, which will help us to predict before time the movement of light and which are very common in Himachal-like places. So, topic of my today's presentation is hidden fluid mechanics. What we will study, basically, we will give brief introduction about hidden fluid mechanics, what is Navier-Stokes equation, neural networks which will be used for our model, and finally we will build our model. What is hidden fluid mechanics? A machine learning in fluid mechanics. So how it is used? A Navier-Stokes informed deep learning framework for assimilating velocity fields. So basically, we will mixing two branches, that is machine learning and Navier-Stokes, to find our results of such as velocity fields and pressure fields. So first we need to know what is Navier-Stokes equation. Navier-Stokes equation is broadly mathematically classified to examine changes, properties during dynamic and thermal interactions. It helps us to find flow velocity and pressure fields. It is second order nonlinear partial differential equation, which can be given as rho partial differences of velocity with respect to time plus v into grad of v is equal to grad of pressure plus rho times acceleration due to gravity viscosity times grad square v. This equation is also known as million dollar equation as it is used in various fields of engineering. Secondly, we need to know what are neural networks, why they are named as neural. Inspired by human brain mimicking the way of that biological neuron signal to one another, are comprised of node layers containing input layer, one or more hidden layer, and output layer. Each node or artificial neuron connects to another has a associated weight and threshold. If the output of any individual node is above the specified threshold, the node is activated and sending the next node network. Thus, neural networks work. So, building our model. First, we will introduce transport of passive scalar field. We will study what are passive scalar fields, why they are used. Then we will be set up our problem, means what we will be dealing with, or what solution we will be coming out with. Building neural network, building our machine learning model using neural network approach of deep learning. Then we will study what are residual networks which can be held for our model. Finally, we will do TensorFlow analysis for image classification and output of data. And finally, we will see results of our model. So firstly, we need to know what is passive scalar field. A passive scalar can be defined as an idealized, non-reactive substance that is transported along the volume of fluid featuring negligible interference with local hydrodynamics. Use of the smoke in wind tunnels or dye in. Now setting up our problem. Passive transport equation can be written in this form. An Navier-Stokes equation for incompressible Newtonian fluid dynamics can be written in this form. Here, RE represents Reynolds number, a dimensional quantity in fluid mechanics, and PEG denotes Beckett number, a dimensionless quantity relevant in study of transport of phenomena of flowing fluids. Given such data, scattered in space and time, we are interested in inferring latent hidden quantities that are velocity in x direction, velocity in y direction, and velocity in z direction, and pressure field for given time interval. Building our neural network. Using two research papers, Physics for Deep Learning and Deep Hidden Physics Models, we can rewrite our function of Txyz in CDUVWP. Here, Txyz are taken as input in our neural. Sigma is used as activation function. Here, two hidden layers are being used. This activation function is used is sin x, finally giving us output as C, D, U, V, W, and P. that is velocity field and pressure field at particular point for particular concentration of passive transport scalar field. Further, we ac further derivating we acquire required derivative to compute residual networks that are E1, E2, E3, E4, and E5 by applying chain rule for differential compositions of function using automatic differentiation. Thus, our neural network works. This neural network is also named as Navier-Stokes informed neural networks. Now, using TensorFlow analysis, we can generate high-resolution datasets for different benchmark problems studied in current work. We have very large amount of training set which gives us different images for our different test examples. In current work, we have employed spectra of HP element solver NECTAR, in which Navier-Stokes equation along with transport equation are approximated using high order semi-orthogonal Jacobi polynomial expansion, and thus we obtain such images as our output. References for the topics is being given in these slides. Source code, source code for physics informed deep learning physics model. Thank you. Hope you like it.